Okay, let's unpack this today.
Oh, yeah. Yeah.
Because it is Thursday, February 26th, 2026. And, well, if you've been anywhere near a financial news feed today, you know exactly what we're talking about.
It's the big one, the neon green giant.
NVIDIA.
Exactly.
And we are doing a deep dive into their Q4 fiscal year 2026 earnings report that just dropped last night.
And what a report it was.
I mean, I have to be honest, I spend a good portion of my morning just staring at the zeros on the screen.
Huh, you and every analyst on Wall Street.
Because the numbers are so big, they almost feel, I don't know, fake.
They do.
We're talking about $68.1 billion in revenue.
In a single quarter.
Right, a single quarter. That is up 73% year over year.
It's a staggering number. I mean, it's a massive beat on both the top and bottom lines.
Yeah.
But, looking through the transcript and the actual reports today, the dollar figure isn't even the most interesting part for me.
Really? Even at $68 billion?
Honestly, yes. It's the shift in the language.
Oh, right. I noticed that too.
Exactly. Because for the last 2 years, the entire narrative has been, chatbots.
Generative AI, ChatGPT.
Right. But if you look at what Jensen Huang and Colette Kress are saying now, the vocabulary has completely changed.
It has.
It's no longer about chatting. It is all about agentic AI.
Agentic AI. That was absolutely the buzzword of the call.
Without a doubt.
So our mission for this deep dive is to basically go beyond that headline beat.
Right. Get into the weeds.
We're going to dig into this transition to agentic AI and why it is essentially changing the entire economic model of the tech world.
Which is fascinating.
And we'll look at the new hardware roadmap because we finally got some very concrete details on the Rubin platform.
And we have to talk about some of those very surprising partnerships.
Including one that I frankly did not see coming.
Oh, the Grok deal.
Yeah, my jaw hit the floor on that one.
I know, it's huge.
We will absolutely get to that. But let's start with this AI factory concept.
Okay.
Because Jensen keeps repeating this mantra. He says, compute equals revenue.
Yeah.
And looking at these numbers, he might be right.
He is certainly proving the thesis, that's for sure.
Yeah.
Let's look at the financials just to set the stage for you. They beat earnings per share, coming in at $1.62 against a consensus of $1.54.
Which is a solid beat.
It is. But the real story, the absolute engine of this growth, is the data center revenue.
Right.
$62.3 billion of that total revenue came just from data centers.
That is up 75% from last year.
Incredible.
And I saw a stat in the CFO commentary that just blew my mind. Colette Kress mentioned that the data center business has scaled nearly 13 times.
Wow.
13 times since the ChatGPT moment back in fiscal year 23.
It's unprecedented industrial scaling. You usually only see that kind of percentage growth in a tiny startup.
Not a company that was already a giant.
Exactly. And this brings us right to that language shift we mentioned.
Right, the agentic AI.
Because why is the demand still accelerating? It's not just more people using chatbots.
No.
It's that the AI itself is fundamentally changing how it operates.
Okay, so let's drill into this agentic AI concept.
Sure.
Because I think for a lot of people, AI is still just, typing a question into a box and getting an answer.
The standard prompt.
Right. So how is agentic different from what we've been doing for the last couple of years?
Think of the old model, the current model for many people as turn-taking.
Turn-taking, okay.
It's conversational. You say something, the AI predicts the next word, says something back, and then it stops.
It waits for you.
It waits. It's passive.
Right. Input, output, silence.
Exactly. But agentic AI is about giving the AI a goal, not just a prompt.
A goal?
Yeah. You tell it, research the specific market, write the code for an application to track it, and then deploy it to the cloud.
Right.
And then the AI just goes off and works. It acts like an employee.
So it's not instantaneous?
No, it might work for minutes or even hours, reasoning through the problem, trying different things.
But it's performing an entire workflow.
Yes.
It's not just retrieving information. It's reasoning, planning, and executing multiple steps.
Precisely. And in the earnings call, they specifically mentioned OpenAI's GPT 5.2 codex.
Oh, wait.
And Anthropic's Claude Cowork and Claude Code.
Yeah, I saw those.
These are just chatting tools. They are performing long-running tasks. Jensen even mentioned that internally at NVIDIA, their own engineers use these agents constantly.
To do what?
To help design the chips themselves.
That is so meta. AI designing the next AI chips?
It really is.
Yeah.
And this connects directly back to the revenue.
How so?
Well, if an AI is working for an hour to solve a complex coding problem, it's not just generating 50 words.
Right.
It's processing millions and millions of tokens in the background.
Ah, I see. So the usage just skyrockets.
Exactly. That is the key metric now. Jensen had this quote that I circled 3 times in my notes. He said, "Inference is revenues."
Inference is revenues.
Yeah. In the past, you trained the model. That was the heavy lifting, the big capital expenditure.
Right, buying thousands of GPUs just to teach it.
Exactly. But now, the heavy lifting is the actual usage, the inference.
Because it's constantly thinking.
Because these agents generate thousands upon thousands of tokens to complete a single task, the raw consumption of compute is just going through the roof.
So companies are willing to pay for that massive compute time because the agent is actually doing valuable, tangible work.
Right.
It's not just a sunk research cost anymore, it's productive.
Exactly. If an agent can write a software module that used to take a human developer 3 days,
Yeah.
and it does it in 30 minutes of high-intensity compute, well, that compute time is incredibly valuable.
It pays for itself immediately.
That's why Jensen says compute equals revenue. It's becoming a raw material for economic output.
Like electricity or steel in the Industrial Revolution.
Perfectly said.
Which completely explains why everyone from Microsoft to Elon Musk to, random startups are scrambling to buy more chips.
They can't get enough.
Which brings us to the hardware side of things. We've been hearing about the Blackwell architecture for a while now.
Yes, the current generation.
What is the status there?
It's the classic NVIDIA story right now. Demand is vastly outstripping supply.
Still.
They mentioned on the call that 9 gigawatts of Blackwell infrastructure have already been deployed.
Wait, 9 gigawatts?
Yes.
That sounds like a lot, but can you give us some context for what a gigawatt actually means in this space?
It's massive. To give you a sense of scale, a large nuclear reactor puts out about 1 gigawatt of power.
Are you serious?
Yes. So we are talking about the equivalent of 9 nuclear power plants worth of Blackwell ships already out there, plugged in, and running in data centers globally.
That is wild. That is so much heat and so much processing power.
It is.
But of course, in this industry, if you're already shipping it, it's basically old news, right?
True.
The shiny new object everyone is talking about is Rubin.
The Rubin platform.
Right. They unveiled this at CES a little while back, but we got way more confirmation on this call. What do we actually know about Rubin?
Well, this is the next major leap. And it's crucial for you to understand it's not just a GPU.
It's a whole system.
It's a platform. It includes the Vera CPU, the Rubin GPU itself, and the NVLink 6 switch.
Okay, so it's a family of chips.
Exactly, 6 new chips in total. But what really caught my eye in the specs was the physical design of the servers.
What are they doing?
They're moving to a modular, cable-free tray design.
Cable-free.
Yes.
So no more of that spaghetti monster of wires in the back of the server rack.
Exactly. And I know it sounds mundane compared to token speeds, but it improves serviceability immensely.
I'll bet.
If you're running a data center with 100,000 chips, cables are a massive point of failure.
Yeah, they break, they get unplugged.
They block airflow, they get tangled. Making the rack modular and cable-free is a huge operational upgrade.
That makes total sense.
But the headline spec, the one for the CFOs out there, is the cost reduction.
Okay, what are the numbers?
Rubin targets a 10x reduction in inference token cost compared to Blackwell.
Wait, 10x cheaper to run?
Yes.
Not 10%? 10 times?
10 times cheaper. And that matters so much because of the physics of money, or rather, the physics of power.
Right. Colette Kress explicitly said on the call, every data center is power constrained.
This is the ultimate bottleneck for the entire industry right now.
Because you can't just build infinite power plants overnight.
You can't. You have a fixed amount of megawatts coming into your specific building from the local grid.
Right.
If you want to make more money in that building, you need to squeeze more AI tokens out of every single watt of electricity you have access to.
So it's an efficiency game now. It's not just about raw speed anymore, it's about speed per watt.
Completely. They highlighted the NVL72 system, that's their rack scale system, and they said it achieves up to 50x performance per watt compared to the previous Hopper generation.
50x performance per watt. That is just staggering engineering.
It's the only way this whole agentic economy works. You have to make the energy usage drastically more efficient to support these massive workloads, or else the electricity bill literally bankrupts the use case.
It's funny, you don't usually think of a chip design company as being in the energy efficiency business.
They are.
Yeah, that seems to be the main selling point now. They're basically selling efficiency.
It is the defining constraint of the AI era.
Uh,
If you aren't efficient, you cannot scale. Period.
Okay, so we have the brain, the GPU,
Yeah.
but you always say you can't just have a brain,
Right. You need a nervous system.
a nervous system.
Hmm.
And that seems to be a huge part of this earnings report, too, specifically regarding their networking division.
It really is. The networking business alone generated $11 billion this quarter.
$11 billion.
Yes. That is up 3.5 times year over year.
$11 billion just for the networking gear. I mean, that's bigger than most Fortune 500 companies' entire revenue.
It is. And it's because of this shift we talked about, moving to the AI factory model.
Right.
You aren't building individual computers anymore. You are building one giant computer that just happens to fill an entire warehouse.
And to make thousands of GPUs act like one single brain, they have to be able to talk to each other instantly.
Without any lag.
And that's where this specific terminology comes in, right?
Yeah.
We hear scale up versus scale out.
Yes. Very important distinction.
I think this confuses a lot of people. Can we simplify that for the listeners?
Sure. Think of scale up as what happens inside the rack itself.
Okay.
That's NVLink. It's like the internal wiring of the brain, making the chips sit right next to each other and share memory perfectly, so they act as one cohesive unit.
Okay, so scale up is the internal cluster, the local neighborhood. And scale out.
Scale out is connecting all those racks together across the massive warehouse. Traditionally, in high-performance computing, that was done with something called InfiniBand.
Right, the specialized networking standard.
But now, NVIDIA is aggressively pushing Spectrum-X Ethernet.
Wait, Ethernet? Like what we use for the internet, the blue cable in the back of my home router.
Yes, exactly that protocol, but supercharged for AI.
Interesting.
By pushing Spectrum-X, NVIDIA has effectively become the largest Ethernet networking company in the world overnight. They recognize that while InfiniBand is great and super fast, enterprise IT departments know and love Ethernet. Everyone uses it.
It's standard.
Right. So they built an Ethernet switch that is optimized specifically for AI traffic.
Because AI traffic is different.
Very.
Yeah.
It handles congestion, packet loss, all the things that normally kill AI performance on standard Ethernet.
So they sell you the hyper-expensive chip, and then they sell you the cables and the switches you absolutely need to make the chip actually useful.
Yes.
It's a pretty brilliant business model.
It's ecosystem lock-in at its finest. You can't really buy the GPU without their network if you want to actually get the advertised performance. You need the whole nervous system from them.
Speaking of ecosystems and lock-in, let's talk about the big twist in the plot today.
Oh, the partnerships.
Because usually NVIDIA just crushes the competition. But this time, they partnered with them.
You mean the Grok deal? Yes.
Yeah. For those who don't know, Grok, spelled G-R-O-Q, was seen as this huge upstart competitor.
A very dangerous one.
Right. They built these LPU chips that were incredibly fast at inference.
Very fast.
People were saying Grok was the NVIDIA killer for running chatbots.
Yeah.
And now NVIDIA has a non-exclusive licensing agreement with them. What is actually going on there?
It's a fascinating strategic move. Jensen actually compared it to their Mellanox acquisition from years ago.
Also,
Basically, Grok has some very clever patented technology for ultra-low latency inference.
meaning making the AI respond instantly without lag.
Exactly. So instead of letting Grok grow into a dangerous standalone rival outside the tent, NVIDIA is just bringing that IP into their own architecture.
Wow. So if you can't beat them, join them. Or in NVIDIA's case, absorb them.
Absorb is the right word. It's all about maintaining the ecosystem. Jensen wants everything to run on CUDA.
CUDA being their foundational software layer.
Right, that is their deepest moat. By licensing Grok's tech and integrating it, he ensures that developers don't have to leave the NVIDIA ecosystem to get that lightning-fast speed.
It keeps the walled garden fully intact.
Precise.
That makes total sense. Keep everyone inside the tent. And they're definitely paying good money to keep people inside. They also announced a $10 billion investment in Anthropic.
Which is just a staggering sum of money.
Yeah.
They are deeply tying themselves to the top model makers. They already have partnerships with OpenAI, Meta, xAI. But putting $10 billion specifically into Anthropic signals, they want to be the foundational infrastructure for Claude.
Especially for that agentic workflow we talked about earlier. Claude is very good at that.
Exactly. They want to guarantee that Claude runs best on NVIDIA hardware.
Right. And it's not just tech companies buying these chips anymore. It's entire countries.
Sovereign AI.
Yes. Sovereign AI.
This is an absolute sleeper hit for them. They reported $30 billion in revenue just from sovereign AI.
30 billion. That's countries like Canada, France, Japan.
Right. They are essentially saying, we cannot rely solely on American tech giants for our underlying intelligence.
It's a national security issue for them.
Exactly. They need their own sovereign cloud, physically located in their country, governed by their laws.
Like national defense, but for data processing.
Data is the new oil, and intelligence is the new refinery. Every nation wants its own AI infrastructure proportional to its GDP.
That makes sense.
That is a massive, entirely new market that essentially did not exist 3 years ago. It's effectively government infrastructure spending now.
Like building highways or dams.
Exactly like that.
It's wild to think of data centers as national infrastructure, like a power grid. But let's step out of the data center for a second.
Okay.
Because there was some really cool stuff on the call about the physical world.
Physical AI.
Yeah. They mentioned the new Mercedes-Benz CLA is going to be using Llama Nemotron.
It's basically a thinking car.
Right. Not just a car that detects a lane line, but one that actually uses a reasoning model to understand the environment.
It's a huge leap.
And then the robotics partnerships they mentioned. With Boston Dynamics and Figure, it really feels like the AI is finally leaking out of the screen and into the real world.
It definitely is. And financially speaking, this is the next massive growth wave they are positioning for.
Right.
Data centers are the first wave. Robots and smart cars are the second. The AI factory creates the brain. And then you put that brain into a physical robot.
But speaking of physical locations, we have to talk about the space question.
I loved this part of the call.
It was so funny. Someone actually asked Jensen about putting data centers in orbit.
An analyst literally asked that.
It sounds like science fiction, but I guess the underlying logic is, what? Solar power is free in space?
Right. Free solar power and space is cold.
Yeah.
So it's a legitimate engineering question.
Uh-uh.
But Jensen's answer was so pragmatic, he went full physics professor on the guy.
He really did. He basically shut down the idea of a giant space server farm, right?
For general compute, absolutely. He pointed out the thermodynamics problem. Space is cold, sure, but there's no air. You can't use a fan. Cooling relies entirely on conduction, radiating heat away into the vacuum.
Which is hard.
It is incredibly inefficient compared to liquid cooling down here on Earth. So the economics of running a massive ChatGPT server farm in space are terrible because you simply can't get rid of the heat fast enough.
But there was a but to his answer.
There was. The but was imaging and edge computing.
Right.
If you have a satellite taking ultra-high-res photos of the Earth, it generates petabytes of raw data.
Tons of data.
Sending all that raw data down to Earth via radio waves is slow, and it's expensive.
So what's the solution?
You put the GPU in the satellite itself. It processes the image up there, finds the actual interesting stuff like a forest fire starting or a specific ship movement, and then it only sends that tiny answer down to Earth.
So it's edge computing, but the edge is 400 miles straight up.
Exactly. NVIDIA is already putting the first GPUs in space. They are owning that orbital edge, even if they aren't building giant orbital data centers.
Okay, so we've been incredibly positive so far because, well, the numbers are just incredible.
Hard to argue with 68 billion.
Very hard. But we do have to look at the other side. Was there any sobering news in this report that you caught?
There were definitely notes of caution in the forward guidance, and the biggest one remains China.
Yeah, they were pretty blunt about it in the transcript. They said geopolitical risk remains unresolved.
They are actually guiding for zero revenue from China data centers for Q1 of fiscal year 27.
Zero.
Zero. That market used to be a huge chunk of their business, like 20 to 25%. The U.S. export controls have effectively cut that off entirely.
And Jensen warned about the long-term impact of that policy, right? It's not just lost money for NVIDIA today.
No, it's the creation of a competitor.
Right.
He said explicitly that Chinese competitors are making rapid progress. By cutting them off from the best NVIDIA chips, the U.S. has basically forced China to build its own domestic advanced chip industry.
It's a vacuum that is actively being filled.
Exactly. Long term, he warned that could disrupt the entire global structure of the industry. NVIDIA is basically watching its own rivals be created out of pure necessity because those rivals have no other choice.
That is a fascinating and maybe scary thought for a company that currently enjoys a near monopoly. It forces market fragmentation.
It really does.
And what about the gamers? I feel like the PC gamers always get lost in these massive data center earnings calls now.
They do, and they're facing headwinds, not because people don't want the gaming graphics cards.
Right, demand is fine.
But because of supply constraints, it's a simple question of opportunity cost at the foundry. If you have a silicon wafer and you can turn it into a $30,000 AI chip with massive
Or a
margins,
$1,000 gaming card.
you make the AI chip every single time.
Yeah, you have to.
Gaming revenue is actually still growing. It was up 47% year over year, which is healthy. But they warn that supply is going to be very tight in Q1. The AI beast just needs to be fed first.
Prioritizing the AI factory over the gaming PC. It makes complete business sense, even if it hurts the loyal fans.
It's just the reality of resource allocation. They're chasing the biggest market in human history.
So bringing this all together, we've gone from $68 billion in revenue to agentic AI workflows, to space GPUs and geopolitical chess. What is the big takeaway for you here?
The big takeaway is the transition. We are moving from the training phase, teaching the AI, to the inference phase, which is using the AI to do actual work.
Right.
That shift is driving a new industrial revolution. NVIDIA isn't just selling chips anymore, they're selling the actual factory floor for the entire digital economy.
And it comes back to that core thesis: compute equals revenue.
That is the mantra. In this new economy, your ability to generate tokens efficiently is the direct equivalent of manufacturing output. If you can generate more tokens per watt than your competitor, you win. It is that simple.
It really reframes how you have to look at a data center. It's not just storage anymore, it's a generator.
Precisely. A token generator.
So, here is a thought to leave you with. Jensen mentioned something super fascinating about the fundamental nature of software.
Oh yeah, the pre-recorded comment.
Yes, he said software used to be pre-recorded. You write the code once, you compile it, you put it on a disk or a server, and you just run it a million times. It's static, like a DVD.
And now it's generative.
Right. It's generated in real time, on the fly, by these agentic AI models. So if all future software is being written and rewritten exactly as it's being used to solve specific problems for specific people in real time.
Does the demand for compute ever actually plateau?
Exactly.
Yeah.
Or have we just invented a resource that is as fundamental as electricity, where the more you have, the more you just find new ways to consume it?
That is the trillion-dollar question right there. If intelligence is a utility, we might just be scratching the surface of global consumption.
Right.
We never looked at the grid and said, okay, we have enough electricity now. We just invented light bulbs, then washing machines, then data centers, then Teslas.
And now agents. It is definitely something to think about while you're waiting for your next software update on your phone, which, who knows, might just be written by an AI while you wait.
Very likely.
Thanks for listening to this deep dive into NVIDIA's future. We will catch you on the next one.
See you then.